All right, a few more random easy things and then one more thing that might be a little challenging. This reaction, A plus B minus creates AB. A is purple, B is clear, AB is clear. So we know that this is the purple side. A purple thing and a clear thing, we're just going to say is purple, and this is clear. I like to label them before I even look at the questions. We've seen the answer of no change before when we were looking at pressure and volume and there were equal moles of gas. We get two other ways of getting no change, and that's if we add a catalyst or if we add a noble gas. It doesn't have to be neon, it could be argon or helium, any noble gas will always get us no change. Catalysts, they speed up the reaction, but they speed it up in the forward and the reverse direction equally, since that activation energy being lowered makes both the forward and the reverse path faster. Noble gases, they're noble, they don't really react with much of anything, so you put a noble gas in here, it's not going to do anything, we're not going to see a change. Those are the easy things. There are these other type of questions where I tell you the color change and I ask you to explain it to me. So let's see. C is added, or even maybe it's C minus, it doesn't matter. Something, X is added, and we see a clear color change. Which way did it shift and why? So ignoring the question, the right side is clear. So if I saw clear, that means it must have shifted right. Because whatever side it shifts to is the color I see. So if I saw clear, it's because it shifted right. Now, why would it have shifted right? Well, if we had an increase if we had a hill on the left, that could make it shift right. Or if we had a hole on the right, that could make it shift right. Anytime we are adding something, other than like a noble gas, anytime we're adding something that is not in our reaction, this random thing isn't A or B or AB, what it does is it comes in and steals something. It bonds to it, steals it, and takes it away. It effectively removes it from the reaction. So if we are adding something not a part of the reaction, it's going to remove something and cause a shift right. That sounds like we must have a hole on the right. C minus is coming in, bonding to AB and stealing it, causing a hole on the right. Now, in your explanations, you can't actually talk about stealing and holes because that's all just my stupid analogy. But if it helps you visualize and get towards the answer, then great. What I would say is it shifts right because C minus is bonding. In your head, you can say stealing, but on paper, is bonding to AB, removing it, causing the reaction to shift right. Anytime we add something, right here, I know that D plus, is going to steal something. I just have to figure out what. If it's stealing something, it means we're making a hole. I just have to figure out where. So if we see a purple color change, it must be shifting left. So it must be stealing something or creating a hole on the left. The question is what? In this case, I have two options. Here there was only one product. So there was only one thing that could be stolen. Here, A plus and B minus, well, what I'm adding is a positive ion. So if it has the choice, it's going to bond to the negative rather than the positive. Again, I know it's stealing something from the left because I see the left side color. Because it's positive, I'm going to assume it steals the negative. So D plus bonds to, make sure, yeah, I don't think I'm cut off. Good. D plus bonds to B minus, removing it. So we would see that it shifts left. I know those are a little trickier, so watch it again if you need to, or try the try problems and ask questions.